Hey everybody, Dr. Imhold here again, talking about the Nobel Prizes. This one is the 1960 Nobel Prize in Physics, which went to one of my personal favorite scientists. It's sort of a myth and a legend for this one project. So it went to Donald Glaser, who won for his invention of the bubble chamber. So science can sometimes be fun too. So now we get bubble chamber, which is cooler than you think it is. Let's get into it. Now, in 1927, C.T.R. Wilson won the Nobel Prize for his invention of the cloud chamber, which is sort of the natural predecessor to the bubble chamber, but a little bit different. But that one was for measuring ionizing radiation. So in 1952, Donald Glaser did the work that ultimately won him the prize in 1960 for using a bubble chamber, which was filled with a liquid almost at its boiling point. We're not talking liquid water here. We're talking other types of liquid, usually in labs more like liquid hydrogen, which is very different than liquid water. But when charged particles go through that chamber, they ionize atoms as they pass by. And when the pressure is reduced, bubbles form around those charged atoms. So you get these little charged spots that form bubbles. And the faster it moves, the more energy it has, the bigger that bubble, slower it goes, the smaller that bubble. But that allows those particles to be tracked and photographed and those measurements to be done, which gives you a lot of data about them. And that allowed much higher energy measurements to be done than was previously done in the past. So this guy took measurements and said, hey, now we can measure these really high energies and we can measure them crazy accurate, which is much different. But that's not the only reason he was sort of this legend, at least for me. So let's take a little bit of a look into what makes him that legend. Now, there's this really cool story that goes around about the bubble chamber that said it was inspired by beer. Bubbles in a chamber had to be inspired by something. He denied it, but in a talk much later in his life, he said, no, it wasn't inspired by beer. But he would admit to having used beer to experiment with early prototypes. So beer was involved here. That's what makes this man an absolute legend, because when you can combine science with your favorite hobbies, who's not going to do that? So you got to love the enthusiasm of this particular guy. Now let's get into a little bit more about what that cloud chamber does. So in these two pictures, you'll see both a bubble chamber and the data that comes out of a bubble chamber. Now, as the bubbles get bigger, that means it's a higher energy particle. As they're smaller, it's a smaller energy particle. And as long as you calibrate them with a known energy, so you've got a particle you run through there, you know exactly what the energy is. You can then look at other bubbles and use that. Hey, here's what the known one looks like. Here's what a couple of known ones look like. We're now calibrated. You can then do some little math and work around to figure out what the energy of the particle you just measured was, because the size of the bubble is proportional to the size of the amount of energy that particle contains, and that gives you a lot of information. So what are these things good for? Well, in 1973, they discovered at CERN what's called a neutral current, which is kind of confusing things, but it basically confirmed the electroweak theory, and that theory basically suggests that two of the four fundamental forces, the electromagnetic force and the weak nuclear force, the nuclear weak force, whichever way you want to say that, are different aspects of the same interaction. So those two fundamental forces are very, very, very related. In 1983, they used a bubble chamber to discover the W and Z bosons. They've detected what are called, really the name, I'm not making this up, strange particles like the omega minus. They actually are a category of strange particles. Meson and hadron resonance have been measured, all kinds of interesting science. They measured scaling in neutrino and nucleon, deep inelastic scattering, which was pretty cool stuff for fundamental science in the particle space. Now they've largely been replaced by other types of technologies, but they do still have a place in dark matter projects. So they are still used from time to time. They've pretty much been replaced by more digital methods of doing things, but they do still play a role in dark matter. Partially because with dark matter, you want these much larger detectors instead of small ones, because you don't know where dark matter is going to hit. Nobody's ever detected dark matter, still into sort of the scientific contention space, but they are still in labs trying to detect that stuff. So pretty cool little project. Beer was actually involved in the prototype, but not necessarily in the development. But yeah, you have to give it you have to give them the props for having used it in the prototype. So very cool invention for the time. Really did help us advance science, and was doing so into the 1980s and a little bit into the 90s. And hey, maybe, who knows? Maybe someday a bubble chamber will actually be the first thing to detect dark matter. It could happen. Thank you for tuning into this video. I hope you've enjoyed it. Don't forget to click subscribe and like and all that fun stuff that helps us out with the algorithms. And we will see you on the 1961 Nobel Prize in Physics soon. Enjoy.